Okay, then I want to say hello to everyone. Welcome to today's webinar. Today we have a very exciting topic. We deal with the topic interfaces with RFEM6 and also Archicad, especially the new exchange format SAF. I would like to introduce myself. My name is Daniel. I am responsible here at Dlubal as CEO for the HR and also for the marketing and sales department. And I will present you today the second part, so the part of RFEM6 in this webinar.
Yes, hello also from my side. My name is Lucas. I work for Dlubal for 11 years now, and I'm working in the field of the steel design, but also in the interfaces. And my job today will be the chat support.
Okay, hello from my side. My name is Guido Bauer. I worked some years in civil engineering, mainly in steel constructions. Now I work at A0 Bausoftware. We are a software reseller located in Vienna, Austria, and I'm helping architects and engineers to improve their workflows.
Okay, perfect. I want also to say thank you to Guido. He's our guest today in this webinar, and I'm looking forward to our webinar. So we can close the webcams. I will go through the presentation. So for those who are attending the webinar for the first time, I have here a short overview about GoToWebinar as platform. So you can show or hide your control panel here with the arrow. You can adjust your audio settings. So for those who can't listen us, check up your audio settings. And of course, we welcome all questions you have, and we are very happy when you can answer them. Okay, so to the content of today. First of all, Guido will show you the structural evaluation and optimization of a reinforced concrete building in Archicad. And then I will take over and I will present you some basic things about the new SAF format. And then also after that, I import the SAF file into RFEM6 and go through the most important, I would say, interface challenges when dealing with exchange models. Okay, I will forward to Guido. I will give him the moderator rights. Okay, perfect.
Do you see my monitor?
Yes, we can see it.
Okay, so the first step to the workflow. Normally it's like this, that the architect is planning the building in Archicad, and then there is an exchange with PDF, IFC or DXF, and the structural engineer is developing his model and giving the loads and the materials and calculating this model. Then when they can exchange their opinions, the architect planned during this whole time on the model and has here 4 or 5 steps further with their modeling. And then there is the problem with the change from the data, and that there are 2 different models and you have to compare it and you have to transfer the whole thing over some formats. And normally this is today done per mail or per cloud. And here is one main problem, that you have 2 models and they are not really the same, but some kind similar, and you have to do several work to improve the content. And we have other solution for this whole problem. For Archicad, there from Graphisoft, there is the BIM Cloud. It's something like this, that the whole BIM model in Archicad is on the BIM Cloud. And then you can, as a civil engineer, go into the model and improve the model, give your feedback in the Archicad model, and then you can save the analytical model from the BIM Cloud, make the calculations in Airframe, and give the information back. For us, this is one really important thing is the model quality. When the structural engineers are in the BIM model, you can improve the whole building and don't have to write the mails, the other things. The second thing is here the whole communications in Archicad with issues or in the futures with BCFs. It's something like IFC, open format, where you can exchange some informations. And as an engineer, you can export, import a whole bunch of informations from the modeling. For the model, the main thing is to save time for the architects and for the engineers. Now I will show you our Archicad model. So I expect that everyone knows what BIM is and what Archicad is. Hopefully it's okay. When you use this workflow, you can go into the BIM cloud or you can get the file and see the whole building, and you have the whole information from the model, for example. So you can also see the sun collectors on the roof and the whole other things from in the model. So I can go now in my view in the third floor, and there you can see our plan. We have the whole information in the model, and this is a bit messy here. This model is our demo house. It's made for something like this, where I can present different problems and see and can show you some improvements or workflows. So this is not a real building. It's a demo house for our purpose to show problems and the workflows. As you can see, we have here the whole information. And as an engineer, I can make here different layer settings so that I can improve my information so that I only see this, what I want to do, I want to see. And here I can also delete the furniture or the floors or the rooms. The next thing is when I see this one level, I can show the one below with only a transparent view and can so see the structure in different areas or sections like this. This is the main thing when we work 2D in Archicad, but the good thing is that we have here the 3D model. In the 3D model, we have different special surfaces where we can cut, for example, here our model and see the whole thing. And this is now important for the next steps, which will come in the future. In the whole building, we have the informations from the rooms, from the furniture and special objects. And so we can see and improve the whole model. We also have a special view so that we can only see the core of the building. So I can change this for the load-bearing elements. And so we see only this concrete model from the demo house. In the next step, I will filter the windows and doors so that we really only see the concrete structure. And here is one of the main things. When I see this model in Archicad, I can say as a structural engineer what is good or what is not so good. So for example, this, I have here my concrete structure and my windows. And here I see through the whole building, which could be not so good for this geometry. And when I change the view here in this direction, I see, yeah, okay, this edge is not so good. Well, I can see here through and there's nothing. So this could be a problem or this will be a problem. The other thing is, for example, here on this side, I see here a window, here this geometry of the walls and slabs. And there I can also say, yeah, okay, this would be not the best solution for this. And then in the old workflow, I have to model the whole thing, can say, yeah, okay, I need a column or something like this, and can write this per mail or with drawings. And then we have to discuss the whole thing. And this you can do in Archicad. We have something like an issue, we have issue management, this is called. And there I can make comments on different things. For example, here in this area, I can create a new issue. I name it 01. And when I'm working in the Beam Cloud, I can give this issue to several people to say, yeah, I can say this have to be done on a special date. It's important, or the person for whom it's meant, and I can discuss the whole situation. For the first thing, I can here make a picture, and I say it V1. And then I have here my building, and I can edit this one picture with my favorite graphics program. And here I can say, yeah, okay, the problem is here the force flow around the roof and the window in this area. And my discussion is, for example, yeah, this would be the better way to have a column here in this situation. So here can you see now the thing with the drawings I made here inside. The good thing is when I change the view, or when I'm still working on the whole project, I can be in every situation. And when I change the view, when I click on the photo and the graphic, I can move in the direction where this picture was taken. For the next thing, I'll tilt to the windows again so that we can see this. One important thing is that we can also include here different parts for the model. For example, here you see the walls here go through, and that there is an edge through the window. And this is not so great for the forces in this direction. So it would be better when the window is moved a bit in the left hand side, so that the force can go straight down. This I can also do in a new issue. And here, when I create a new issue with the other number, okay, it exists already. Here's the same thing. I can give this to a special person or date or comment it. And when I create this issue, I can also include parts in it. This is, I can say this window should be modified. And then I can say, yeah, okay, it should be moved in this direction, for example, 30 centimeters. Then I have this information in the model. You see it here. Blue is the new geometry, red is the old geometry, and it's saved in the old geometry. And for that, I can now send this issue to my architect, and he can say, yeah, okay, we can discuss this, or I can accept it. And with the accept button, he accepts the geometry, and it is changed. And I said, excuse for that, I moved the window, not the window, I moved the wall, but it's the same thing, not the walls, it's the window. I will show you that on another example with a column. I think it's a bit better for the understanding. When I have here a column and it is created, I can here now say, yeah, okay, it should be modified. So it becomes here yellow. And now when I move the column, you see in the model is the old column red. This is the old standard, and the new column is green. And then when I accept this change, the model will change for the new column. And now it's blue because this is an active issue. And we have not only this one surface for the issues, we have also a whole window for the whole organization for the windows. And I can here show issues or not. And so it is a bit colorful so that you better understand the model. One last thing for our views is that we can now give some graphical override to our model. Here, for example, I can show you something I've done for my structural view. I colored the slabs and beams in cyan, and the walls and columns in green, and the openings with the yellow pen. So you can see the whole building and understand the thing. On the other way, I can also give information in the model. So this every element has now several topics. For example, I here filtered it in different part of the building. I give here the material or a status in which it said, is it finished or is there a problem? And so I can now say and communicate with my colleagues about the thing. So here you can see that the cellar or basement is finished, and these two areas is red, so it's not finished, and the problem is they will think we haven't done it. Here I have different opportunities to improve my workflows and communicate with the older persons in the project. Now I'm coming to the next thing, to the analytical model. We see here in Archicad that we have the whole construction for the concrete walls and slabs. And now we have a second view where we can create from this geometry the analytical model. I click here on one button and it is calculated. And now we see it here in that we get now the slabs and the beams for our geometry. And this I will show you in another model because it's a bit better for the understanding. In Archicad, we have several different elements. We have walls, slabs, roofs, columns, and beams. And everyone has a core. One material is one material, but we can also have on our one wall different materials. And yeah, one thing, the concrete is always the core, and it is called like that in the model. And so we can translate here this geometry to different surfaces and columns and beams to beams. And when I create now this model, you can see here the surfaces in the wall and in the roof. And here you can see now that the beam is only the core, the steel core in the whole construction is used for the beam. Now we have this element, and out of this element we create our model. Here is a small example, and normally when you export IFC models, you have one problem in your statical model, that the whole geometry is not correct. You see here the gaps between the surfaces and the other geometry. And for this, we have in Archicad rules, and I will show you the main thing here in this one setting. We can create a different rule set, export and import them, and normally it's always the same thing. The logic is very simple for this whole thing. I add a new rule, and this rule says that we had a wall, and it will be stretched to the next wall. And when I do this command and edit, you can see that here is now the wall the connection with the other wall. When I make the next rule, I can say that the walls should be stretched to the slab. And the next thing we can say that the slab should be stretched to the walls. And when I now create this geometry, you see that the connections are correct. Now there are some different things. For example, I have here a hole which is smaller than my element in the statistical calculations. I can say, for example, that all holes which are smaller than half a meter should be ignored. Some things I can here write into the rules so that here the holes are ignored in the model. I have prepared the whole thing for this model, and normally this rule set is quite the same, and normally it is really good. And here you can see the different things. You have here now the whole correct model with the openings in the slab, and in this area the one hole is ignored. In the next step, often you have different slabs in the size. And there you have normally the problem that you want to have the whole flats in one level. And so you can add this once with the rules, and in the other way you can edit this in them when you take the slab and you can grab it and change it with the mouse. And you can also change here, for example, the geometry, the position of the beam for the beam. Okay. The last thing I will show you here is that you can also translate the column and the beam in different elements. Here you can see that I have here different cross section over the whole column, and normally it will be better when I have one cross section for this kind of column. In the other way, here you can see a beam, and this is not a normal beam, this is a beam, so I can show what is possible with the software. Here you can see that I have here different sections with different cross sections for my beam. And normally it should be cut, and so you have here several beams with always a start and the end cross section for your analytical model. And now the last thing from our geometry in Archicad, we have not only the structural geometry for slabs and beams, for example, we have also the rooms and much more information. And here we can now say that for the room, we can create automatically the load for our model. For this, we have here under design structural elements, there is a generator for live loads. And when I click this one, it automatically creates the load here for my slabs. This I will show you now in my improved model when I find it. Okay. Here I have improved the model from before. I've changed this edge because it's better when it's here straight, and I changed some other things. When I click here now on the model with the correct rule set, you see here it's everything quite right. I have here the most lines. Some things are not really ideal now. The thing is, the model is that Archicad can create the analytical model. It's since 2020. Archicad 24 was the first version. Now, 2 years later, we have a really good model, but here some issues like this thing. Sometimes something like this happens, and sometimes I have a second note. Yeah, the model will be better, and we see what today is possible. In this model, I have changed some things like this here, that I have here created some walls that is a bit stiffer in this area. And I also created here the supports for the buildings that we can see here, the walls in the basement. Now what is possible for our export, we can export several files. For example, we can export here our Archicad model, but also we can export the DXF, or we can export the RFC model. For us today, normally we export the structure and analytical model. And here we have one thing also to do. We have something called translators in Archicad. And so here we can translate our information from our material into the material for RFEM or other things like the geometry for our cross section or something like this. And this is the end of my presentations. So you can see as a structural engineer, when you go here in your model or you can cooperate with the architects, you can improve quite easy the model and save some time. Okay.
Udo, thank you very much for this impressive presentation of Archicad. Looks very nice. I will continue. So I will make me as presenter. Okay, so let's go through the new format called SAF, Structural Analysis Format. Gudu has shown you a little bit something of that in Archicad and also the export of this file. This file is pretty new. To put the file into the whole BIM concept, I would like to start with the basics. And the basics are the topic or the technical term interoperability. So when dealing with BIM and also with exchanging models, there we have different interfaces. So first of all, we have the interface, the direct interface when dealing with native files. You can imagine it when you would like to transfer an RStep file and you want to open it in RFEM. In RFEM, this would be a direct interface with the help of native files. Then you have the direct interface. Direct interface means that different software companies are communicating based on APIs, application programming interfaces. So there, the databases of two different software applications are linked. And then on the right side, we have the third variant, and this is the open indirect interface. So this means you work with open formats like IFC or also SAF. And what does it have to do with interoperability? So the interoperability is nothing else than the ability to exchange data between applications with as little loss as possible. So this is the basic concept of BIM and also the exchange of models. So now let's focus on the open indirect interface. So in order to have maybe a little bit comparison to SAF, I would like to start with the IFC. Why IFC? IFC is mentioned as the open BIM format, and therefore it's quite good to understand, okay, where is IFC good and where is SAF better? Because the direct interfaces, they are quite okay when dealing with applications like, I don't know, Revit or RFEM. This works pretty good, but some engineers who don't have these applications, they can't participate into that BIM process. So to work with direct interfaces, it's called like a closed BIM. So you need these software applications. So it's mandatory to participate, to attend this BIM process. And now with open BIM, so with IFC formats and also SAF formats, you can work with almost every software. So in order to compare it, I would like to start with the IFC. So regarding the IFC, it may work for some applications like coordination models or the carrying out of collision checks. You can also do your cost calculations, do some visual simulations. For all these application areas, the IFC format is quite good. Yeah, but what we as structural engineers need to do is the exchange of structural analysis models. And there it can be complicated. And why? I will explain it to you right now. So First of all, you have to know that when working with IFC, mainly in the structural engineering part, you have to know that you work with two different languages, I would call it. Yeah. So on the one side, we have here the physical structural model, and we as structural engineers in our structural analysis programs, we work with an idealized analysis model. So the IFC has also two views. On the one hand, the reference view, the coordination view, and on the other hand, the structural analysis view. So basically, the CAD programs model the components as volume models. And we as structural engineers, we model instead of walls or concrete slabs, surfaces or lines, members. Yeah, so CAD programs and structural analysis programs are talking two different languages. So, for example, this case. So, vice versa, when I want to vice versa from CAD programs to structural analysis programs. CAD programs usually display the structural elements as solids. So you see here the surfaces, and then we have here also two different representations forms. On the left side, you see here the BREP, so the boundary representation, and on the right side, the swept solid as drawn body here. So the biggest challenge is now to create from a 3D element, which is normally a volume or a solid element, a line or member, so a 1D element. And this is the biggest challenge in the exchange of structural analysis models between CAD programs and structural analysis programs. So when you transfer, for example, exported IFC data into a structural analysis software, not everybody is working or can implement it as you want to have it. For example, here in this case, it often looks like there are no connections when you import here an IFC, because the CAD program wrote this IFC as a physical or a coordination view. And when you import it to an structural analysis program, then they are missing the links between the structural axis of the objects, like from the column or here from the surfaces. So you see here the gaps. So, and why do we have this situation? Why didn't the software vendors improve the whole situation? So it's quite easy to answer this question, because they were quite early with the implementation, but there was no market for it. So in the 2000s, they started to improve this workflow, and the market wasn't ready for that. So this was also the reason why the IFC structure analysis view wasn't implemented in the whole CAD world. So there was no demand from the market. So this is also one of the difficulties of the IFC. Moreover, you have also another difficulty of the IFC. It is a really complex, huge, and hard to read format. So you can open the IFC in almost every text editor, and when you open it, you see here that it's really hard to understand what you can do here with that format. So what we can do now is the following thing, that the aim of the new format is to counteract these disadvantages and difficulties of the IFC, and to focus on the advantages what structural engineers really like to have. So structural engineers like to have an easy to understand format. The best way would be a kind of Excel format, or kind of spreadsheet, something like that. So the SAF, called structure analysis format, is an Excel-based exchange format. The focus is really on the exchange of static or structure analysis model, and it was developed by SIA and the Nemetschek group. So the advantage is that every civil engineer, because of the simple language, can understand this format. So how is the structure of this format? So basically, a SAF file can be divided into 4 components. On the bottom part, we have here different, I will call them object types. So we have here the structural curve member, structural point connection, cross-section, material, model, project. So, and each object type, so each list, contains a bunch of information. So at each row, you find different information. Like in this column, you find here the nodes, for example, of a member. So the beginning node and the end node, you find also the length, and each cell has also a value. And the value is, for example, the beginning node here in this row. So this is the basic structure. I will show you it afterwards. Okay. What do we have as other characteristics of this SAF format? So as I already told you, we have the Excel format. It's a relational database. Relational means similar to RFEM 6, you have different links. So different relationships between the tables with which different objects can be linked. So for example, you have member, for example, so the structural surface member, and this consists of a structural material and also a structural cross-section. And each of this information are listed into different lists in this SAF format. So what can we support as element types? The normal structural data, loads, hinges, supports, and also 1D results like internal forces. So for everyday use, there are sufficient types for simple structural modeling and calculation. So where do we see the opportunities and advantages for you? Mainly in the simple and easy understanding format. This is a real advantage. You open it into Excel, everybody has Excel, and you understand immediately what the SAF format can do. Then also another advantage is the small file format. So when, for example, Guido finished with his Archicad model, he export the SAF file, he can send me this file via mail or put it or store it into kind of cloud. So the file is not huge in comparison to an IFC file. And it's very suitable for exchanging structure models because there is the focus. And combined with IFC, it can be very effective when you focus on the advantages of both formats. So IFC for the collision models, coordination models, visualization, and so on, and SAF for the exchange of structural analysis models. So when you would like to know more about the SAF file, I can recommend you visiting this website. I can open it for you. So here, this is the website, SAF guide. Here you find very informative documentation. This whole development of the SAF is done by SIA. They are very open to invite also other software companies to let them implement their format. So for example, when you go here to who supports SAF, you find different structure analysis software companies who are supporting this SAF file, and also different information about the object types. So how looks this SAF format? So I will call the send SAF file from Guido. So I have opened it here, and you see here the following thing. So we have here the the different object types, so the different lists, like project, so you find here the basic information, model, structural material. In this case, we have only one structural material. So maybe for those who are working with RFEM, it can be a little bit similar to our tables. Also structural point connection. This means, okay, different nodes with a different coordination, and always here these IDs. So for round tripping, so when you want to make here some synergies and you changed maybe the information of one node, but the ID is still the same, the other program recognize it and just change the geometry information, for example, but not the ID. Then also structural surface member, opening and point support and so on. Okay, so much to the format. I think this is pretty intuitive and also easy to understand. So when you would like to import it into RFEM 6, I will call RFEM 6. You go here to File, Import SAF. So I import it here. Okay, I have to close SAF because it's currently used. Now it should work. So, perfect. So now you see here the conversion tables. You can do this here in RFEM 6, or the other way is, as Guido has already shown, it's to you that you can also do this in Archicad. I click here on OK, and every time when I work with different interfaces like importing DXF files, SAF files, IFC files, or also using some direct interfaces, I, as structural engineer, need to do some checks. So the first checks, in my opinion, is always the completeness of this model. So I will do here some basic checks if the connections of the systems are correct. So in my opinion, in the first view, it seems everything okay. So this looks pretty nice. Maybe here some smaller things like this balcony surface that for the generation of an FE mesh, I can change here the coordinate of this node. Oh, this was a mistake. For this node, and here the same. Just change here the coordinates, and then I have here a clear system. So much to that. So really check here the geometry. Okay, the next thing is also maybe a kind of material checks. So I have here this material. When I go through it, it seems that all materials are there and were imported correctly. I have also here these other two materials, but these were from projects before. Also the same with sections, but in this case we don't have any sections. And these are the next things to check. Okay, the next part would be very important thing, the tools that we have here, also some model check opportunities. So I would recommend you always using here these identical nodes. So you can check here the identical nodes. If the nodes are too close to each other, check here the distance, the tolerance. In this case, we don't have here anything. Maybe let's try it with 1 centimeter. Okay, looks pretty good. Okay, check done. Now let's do another check. Overlapping lines. Okay, and there are some, I would say, not difficulties, but maybe some challenges. So it would be good when you don't have any overlapping lines, because it can cause some problems regarding the FE mesh generation. So I would improve it, or I would find here a solution for that. So what are overlapping lines? Maybe, for example, I will show here it to you for this elevator box or surfaces. When you go through here these surfaces, you see here the different the surface from the from this floor and also from this floor, and also the boundary lines. And the boundary lines of the surface here on the bottom, here, this for example, this is clear, but then you have also boundary lines for the upper surface. So for example, for this here, and then you find here two different lines, because the one is the boundary line for the surface on the top, and the other one is the boundary line for the surface on the bottom. So there are two boundary lines, and this can cause to some problems. So how to solve them? Pretty easy. We have here a brilliant function in RFEM 6, which allows you to connect or to to connect selected lines. So do the following thing. I cancel the visibility mode. Go here to the brilliant function called connect selected lines and draw a selection window over the whole building. And then you see that you will not have anymore these kind of overlapping lines. So go here back to tools, model check, overlapping lines, and you find here anything. I will save here the model. And I will do the check here again. So model check, overlapping lines, and you won't find any overlapping lines. Okay, so much to that. So then I will generate the FE mesh. And this worked, so this is a good sign. Then in order to evaluate the quality of the FE mesh, I go here to the display navigator, go here to the area mesh quality, activate them, and just show me here the part of the warning surfaces. So, and here I find maybe this kind of field. So when I go a little bit closer to that, you see, okay, that here the FE mesh is not, is too rough. Yeah, you have to be here by far finer. So maybe here some FE mesh refinements, then you are on the safe side. Okay, but we can neglect this for this simple example. Maybe also here you could do something similar. Yeah, but all these are really small. Locations. Okay, so the next thing is when you do this check, evaluate also the plausibility for one load case, and the most important load case is the self-weight, and evaluate the deformation. So I will calculate here the load case 1, so in this case the self-weight, and I will go through the deformation. So, and when I take a closer look, the deformation looks quite okay. Yeah, it's pretty normal here. So because here we have a large deformation because of the long span of this structure of this surface, but this is normal. Maybe also take a shorter look to that part of the building. And here we have the same, looks also pretty okay. And yeah, these are the most important plausibility checks when working with models, structure analysis models, when using a kind of interface, or when importing some formats or a kind of direct interface. So much to that. Yeah, and this was in general the basic concept of the usage of the SAF format together with CAD program as Archicad. So you saw basic workflow between architects or also structural engineers who are working with Archicad, and how to import it into RFEM 6. Now you know, okay, there are next to IFC also something else, SAF, SAF format, structure analysis format, and I would say try to collect your experiences with a new format. And therefore, I can really recommend you also to visit our website. So to visit our website, go here to the free full trial versions, download here RFEM 6 and also Archicad and try to collect some experiences how to use the new SAF format, especially when transferring structure analysis models. And one thing more I would like to show you is we have also a new extranet. So for those who didn't know it, it's your personal account. So here you find different information about your company, also about your users, about your license, and also about the development. So click here to the part of development and you can be a kind of interactive user who can also influence the development of our team, because you can submit feature requests, and can watch your requested or your submitted features. And every week we publish a new version of RFEM 6, and we are here very transparent regarding the presentation of features and development. And I would really recommend you just take a look here and see what was, for example, the last week new, what we have integrated, what we have implemented. So take the chance, download your RFEM 6, the trial version, and take a look to the extranet to your account and enjoy structure analysis with RFEM 6. So this was our webinar to the interface SAF with Archicad and RFEM 6. I hope you enjoyed the training. I want also to say thank you very much to my colleague Lukas Hühnel and also to our guest Guido Bauer. I wish you as attendees also a lot of fun with both programs, Archicad and RFEM 6, and wish you also a nice week. Goodbye.